This is another example number 3 of your textbook. This is another kind of a question related to the logic circuits. Over here we will build the logic circuit and the construct the truth table if it is required. So the question is related to wind turbine which has a safety system which uses three inputs to a logic circuit. A certain combination of conditions results in an output x from the logic circuit being equal to 1. When the value of x is equal to 1, then the wind turbine is shut down. The following table shows the parameters are being monitored and form the three inputs to the logic circuit. So the parameters description is turbine speed, bearing temperature and wind velocity. So the parameters are for turbine speed it is S, bearing temperature it is capital T and wind velocity it is capital W. They has the binary values with their description of the condition. So if the binary value for turbine speed is 0, then the description of the condition is less than or equal to 1000 rpm. So move further to the conditions over here. Either turbine speed less than or equal to 1000 rpm and bearing temperature greater than 80 degree, or actually these are the three statements. They are interconnected with OR gate, that is over here. OR gate. This is also an OR gate. These three of the statements are further divided into sub statements, which uses in this case they are using the AND gate between each statement. So first of all we will convert this statement into the logical statement. So starting from the first statement, that is turbine speed less than equal to 1000 rpm and bearing temperature greater than 80 degree. So first of all see turbine speed. The parameter for turbine speed is S. Turbine speed is less than 1000 rpm. So for the 1000 rpm that is 0, binary value is 0. So it will be S is equal to not 1. This is the AND gate, and bearing temperature T, the description of the condition is greater than 80 degree. So for T greater than 80 degree, that binary value is 1. So T, we will write T is equal to 1. So this is our logical statement. For the second line, that is turbine speed S greater than 1000 rpm. So for greater, that is 1, S is equal to 1, and this is AND gate. Wind velocity greater than 120 kph. Wind velocity W greater than 1, so binary value is 1. So W is equal to 1. And the last one, bearing temperature is T less than or equal to 80 degree, that is has the binary value of 0 over here. So T is equal to not 1, and wind velocity greater than 120 kph. So wind velocity greater than 1, that is 1. So W is equal to 1. So these are the three logical statements for the given scenario. So now we will construct the truth table for each of the logical statement separately, then we will combine it together. So for this, that is 1, that is 2, that is number 3. So for 1, that is s is equal to not 1 and t is equal to 1. So we will construct a logical circuit for this. So for s is equal to not 1 and, first of all there is AND gate used. S not 1, that will be the input this, and t is equal to 1. So this is the output. For the second one, that is s is equal to 1 and w is equal to 1. So there is AND gate used. AND gate s is equal to 1 and w is equal to 1. This will be the output. For the third one, that is t is equal to not 1 and w is equal to 1. AND gate, I will draw it over here. That is AND gate, t is not 1, this is t, and w is 1, that will w. So we will now combine all of these three logical circuits according to the sequence of this statement. So first of all, there is turbine speed, either statement. So here it is AND gate, not for the s, and this is the input of t. So this was the stage 1, in which we have combined two of the statements, that is this one and this one. Now we will add the third one also. For this we will draw our logical circuit again. That was stage 1, now it is stage 2. AND gate over here, NOT gate for the input value of s. This will be the input value of t. Again another AND gate. So that was not gate. This was the condition statement 3. Now we have drawn the three of the statements with their logical circuits. Now coming back again towards the question, we have made the logical circuit of these statements. Now we have to combine all of these statements. So there are gates used over here, that is OR and OR. So we will use over here OR gate. Its output will be its other one's input, and this output will be the OR gate's input, and there is our final output, that is X.